In this example, we're going to solve this system of linear equations by graphing. So you'll see the first equation is in point-slope form. So the first thing we can do is grab the point from the equation, and then we can use this slope of positive 2 to create more points. So the initial point that I'm going to use from this equation, the x-coordinate will be a negative 2, because from the general form of the equation I'm going to change this sign. So negative 2, and my y value is a positive 3. Again, changing that sign because of the equation. Okay, my slope is going to be a positive 2. So that's enough information to graph this first line. So the second line here, my slope, I can see, is going to be a negative 2/5. That's the coefficient of my x value. Since this equation is already in slope-intercept form, my starting point is going to be this y-intercept, which is 0, negative 5. So the first equation was in point-slope form, so I grabbed the point and I have the slope. The second equation was in slope-intercept form, so I grabbed the slope and the y-intercept. So now, since I have that information for both lines, I'm ready to graph these lines. So for the first one, we're going to start at negative 2, 3. So negative 2, 3, and I'm going to plot that ordered pair. And I'm going to use this slope of positive 2, or we could say 2 over 1, to create more points. So I'm going to go up 2 and over 1. I can't go any farther because I've run out of graph, but I could go down 2 and back 1 to create more points going to the left. So I can do that a few times here. Okay, so now I'm going to grab my straight edge and go ahead and draw that line. Okay, so there's our first line. Okay, our second equation is going to have a y-intercept at negative 5. So I'm going to go ahead and graph it at negative 5 down here. And then my slope is negative 2/5. So I notice I can't go down 2 and over 5 because I've run out of graph, but I do know I'm going to have a downward slope here. It's a negative slope, so it's going to go downhill as I run from left to right. So I can't go right, so let's go left. So I'm going to come up 2 and back 5. Ah, here's this other point. And that right there will be the point that they share. So let's grab the handy-dandy straight edge here. Go ahead and draw this line. Okay, so the point of intersection is going to be this ordered pair, negative 5, negative 3, negative 5, negative 3. And this point, this single point of intersection, represents the only ordered pair that will satisfy both equations. So the solution to this system is the ordered pair negative 5, negative 3. And if we were classified this system, it would classify as consistent and independent.